Nuclear power plants. What is a nuclear power plant? A nuclear power plant generates electricity by harnessing the thermal energy released by controlled nuclear fission. The thermal energy is used to generate steam that drives a steam turbine connected to a generator that produces electricity. The fuel that power the nuclear power plant and allow for the controlled nuclear fission are radioactive materials. A fission reaction is when the radioactive material absorbs a neutron. At that time, it may undergo a nuclear fission, which results in the heavy nucleus splitting into two or more lighter nuclei and resulting in the release of kinetic energy, gamma radiation, and free neutrons. The neutrons released may in addition be absorbed by other fissile atoms and trigger further fission events. The entire nucleus reaction process is nonlinear and highly dangerous, which results in the observability and controllability of the reaction process being very difficult and at times unknown. Given the reaction process not reacting as modeled or the safety measures not functioning at any given time, a catastrophic failure could occur at that time, which would destroy an entire ecosystem. The importance of nuclear power plants. Many countries depend on nuclear power plants as their primary source of energy and tool to reduce carbon emission. For example, in France, 72.3% of their energy is produced by nuclear energy. Nuclear fuel is cheap and produces no CO2 emissions. Every year, scientists and engineers are learning of new methods to make the process safer and usage of radioactive materials more efficiently. Ignoring this clean source of energy is impossible, yet in the future, will it be as important as it was in the past?
Electricity was generated by a nuclear reactor for the first time ever in 1948 by a power plant in the US, which initially powered a light bulb. The first nuclear power plant to generate electricity for a power grid was in 1954 by the Soviet Union. Canada's first nuclear power plant began operations in 1962. The nuclear power industry grew rapidly in the 1960s. By 1970, 84 nuclear power reactors were in operation worldwide, with a combined capacity of around 18,000 megawatts. Accidents like the one at 3 Mile Island in 1979 and Chernobyl in 1986 slowed down the growth of nuclear energy in the 1980s. However, there is still some progress, and in 1983 nuclear plants generated more electricity than natural gas in the US. Improvements in technology and demand for electricity has led to an increase in the number of nuclear plants worldwide. As of today, nuclear power plants have increased to around 450 worldwide and generate around 10% of the world's electricity.
So for the perspectives from supporters of nuclear energy, when compared to other means of energy production, nuclear has by far the lowest rate of direct fatalities per kilowatt hour of energy produced. The benefits of nuclear energy extend far beyond the production of clean energy. Advancements caused by nuclear technologies range from water desalination and medical equipment sterilization to space exploration and cancer treatment innovations. Nuclear energy provides large amounts of carbon-free electricity, which is crucial in protecting the environment. Power that it produces is without a trace of nitrogen oxide, sulfur dioxide, particulate matter, and mercury, all harmful to the ozone layer. And the nuclear industry supports local economies and millions of dollars in state and tax revenues, and provides well-paid long-term jobs. According to the Nuclear Energy Institute, around 400 to 700 jobs are created for a new power plant built. Now for the perspectives from opposers of nuclear energy. As nuclear technologies become globally available and people are more aware of their potential, the risk of these falling into the wrong hands is increasingly present. This creates a concern among people that the development of those technologies will increase the likelihood of proliferation of nuclear weapons. And lastly, as we know, there is a very important risk associated with the accidents caused by human error. Past nuclear disasters caused the relocation of hundreds of thousands of people, millions of dollars spent, a significant rise in cancer rates of populations living in proximity, and the deaths related to radiation exposure are being recorded to this day.
Nuclear power comes with persistent public concern due to the potential nuclear disasters and the radioactive waste. However, nuclear electricity makes up more than a third of global low-carbon electricity, and in a world shifting towards low-carbon emissions, nuclear power is essential. The Intergovernmental Panel on Climate Change released various models for a sustainable energy future, where the increase in nuclear power generation by 2050 ranges from 59% to 501%. While the concern about radioactive waste and nuclear disasters are still valid, new technologies such as small reactors and fast reactors can go a long way in increasing the sustainability and efficiency of nuclear power. Fast reactors have been around since the beginning of nuclear power, but have eluded commercial capacity due to the high cost. However, with the emergence of new technology, the fast reactor industry has re-emerged with over 16 projects approaching deployment. Countries such as the US, Russia, China, France, and many more are responsible for these projects, some of which could become commercial. The appeal of fast reactors stems from the efficiency in which they use fuel. They recycle the used fuel in such a way that nearly all of the uranium ore is used as opposed to the 1% used in the existing nuclear reactors. This efficiency can output 60 to 70 times more power per kilogram of uranium, resulting in significantly less waste. Small reactors, which produce less than 300 megawatts of electricity, can be built with enhanced safety measures. They can be produced modularly and then transported. This will decrease the cost and increase the accessibility of these reactors for developing countries with smaller electrical grids. Most of these developing countries use fossil fuels, and having them switch to modular small reactors can put a dent in global carbon emissions. Both of these kinds of reactors can increase production and help with the sustainability of nuclear energy, which in turn can help us get to a low carbon future.